This is the solution to question number 3 from our second practice test. Okay, let's look at the facts of the problem. We are given two functions f and g, and they define f of x to be the square root of x, and they define g of x to be 6 minus x. Now, for part A, we have to find the area, so that's the area between the curve and the x-axis. So we know to find area, we take the integral of our function. Well, look at this. The function actually has, we've got two parts here that we have to find the area of. First of all, the limits would be 0 to 4 of f of x. That'll give us the area under that curve, plus then the area from 4 to 6 of g of x dx. Okay, now we can substitute the functions into the integral. So we have the square root of x dx plus the integral of 4 to x of 6 minus x. Okay, now we need to take the antiderivative. So we're going to have x to the 1/2, and then it's 1/2 of that, right, folks? So we get, no. So it's x to the 1/2. But when you take the integral, you're going to add. So 1/2 plus 1 is 3/2. Whoa, 3/2. And then we divide by the new exponent, which is 3/2, or in other words, multiply by 2/3. And we're going to evaluate that from 4 to 0. Now, on this expression, we could do this two different ways. We could take the antiderivative and evaluate it, or also, since I notice it's a triangle, I could just go 1/2 base times height. So 1/2, the base is 2, and then the height is 2. Might make it a little simpler there. So now I'm going to continue my work right here. So I'm going to have 2/3 of the quantity 4 to the 3/2 minus 2/3 of the quantity 0 to the 3/2. Okay, we like that. And then we're going to add half of 4 is 2. So the square root of 4 is 2, cubed is 8. 8 times 2 is 16/3 minus 0 plus 2. Okay, so 2, another way of writing 2 is also to be 6/3. So 16/3 plus 16/3 is 22/3. So that would be, they did not give us any units, so it's just units squared. But usually if they don't give us units, I don't have to respond in units. Great. Now let's go on to question B. So now we have the region R as the base of the solid, and we're going from 0 to 2, and we're going to build some cross sections on it, okay? What are we going to build? Well, we're going to build rectangles, and we know rectangles is base times height. And they tell us the height is 2y. What do you notice immediately? Well, the height is in terms of y. So therefore, then, my functions need to be in terms of y. Okay, so let's rewrite each function in terms of y. So at this point, we have y equals the square root of x. So if I square both sides, I get y squared equals x. Nice. And then we have y equals 6 minus x. So subtract 6, y minus 6 equals negative x. So therefore, x will be 6 minus y. Okay, so now we're going to build rectangles here. Okay, so we know the height is 2y, but then the base of or the length of the rectangle, we always go right minus left. Okay, now remember it's in terms of y, so I'm going to go from 0, and the height is 2, and we go right minus left. So then it's going to be 6 minus y, subtracted from the other function, y squared, so that's the base of my rectangle, times the height, which is 2y, and then dy. Fantastic. So now we've written the integrand, and do we have to evaluate this? So write, but do not evaluate. Okay, that's my final answer then. Great. Now let's go on to part C. So part C then, we are told there's a point P on the graph of f, at which the line is tangent to the graph of f. So I need basically the slope of my f of function, and I'm going to need a point on that f of x function. Now they tell me that the graph of f is perpendicular to the graph of g. Well, we know perpendicular slopes are opposite reciprocals. But what is the slope of g? Okay, so if I look at g and I want the slope of g, we see it's a line, so it is a constant slope, is -1. Therefore, a perpendicular slope of f would be the reciprocal, which is -1, but opposite. So my new slope is going to be 1. Nice. So we need to find out what x value do I have a slope of 1. Well, the derivative of the square root of x, so I have f of x equals the square root of x. So if I take the derivative of x, so it's x to the 1/2, So I'm going to subtract a 1/2. So I get x to the negative 1/2, and I bring the 1/2 forward. So another way of writing that is 1 over 2 radical x. So when will 1 over 2 radical x equal 1? Okay, so I do my mathematics and I end up with x being equal to 1/4. Now I need the point, so if x is 1/4, then what is y? Well, the square root of 1/4 is 1/2. Okay, so we just had to find the coordinates of P, so that would be the coordinates of P. And that is question 3.